All right now. So in 4.4, number one, you probably want to know this chart. The chart is very helpful, like if you see certain things. I did one that was quadratic in the first example, and then right now I'm going to do one that looks like a sine of something. So what we're doing is, on this second example, I'm just going to look for y of p, but just remember the last example, you put both the homogeneous, and which is y of c, y sub c, sorry, and then y sub p together. You add those two together. So what I want to do is just go over how to find a particular solution when you're looking at the 2 sine 3x. Okay, so what you want to do is make your y of p equal to, if you notice here, right, the angle itself stays the same, so that 4x will stay the same. In our case, right, our angle is 3x. So what I'm going to have is a cosine 3x plus b sine 3x. And then you're doing the same thing that we did last example, where you're taking, so this is going to be negative 3a, the derivative and the second derivative of y of p, y sub p, right? So here you get negative 9a cosine 3x minus 9b sine 3x. So you have these three. You have the function, you have the first and second derivative, and what we're going to do is plug each of these in to our function here. So I'm going to have equal to, so my y double prime is going to be negative 9a cosine 3x minus 9b sine 3x, and then I'll have minus the negative 3a sine 3x plus 3b cosine 3x, and then a plus the last one, which is a cosine 3x plus b sine 3x. All right, so the next thing that I want to do is just to like combine everything together. So you can see, like, a cosine 3x, you have negative 9 and you have an a, so that's going to give me negative 8a cosine 3x minus 8b sine 3x, and then we have plus 3a sine 3x minus 3b cosine 3x. And what I'll do is just group things together. So I have 8a minus negative 8a minus 3b is with my cosine 3x, and what do I have here? Plus negative 8b, sorry, plus 3a sine 3x. So you can see how I start grouping things together, and then I'm trying to compare that to the 2 sine 3x, which we have up here. So if you look here, you could see, like, here is with the cosine, but there is no cosine there. So because there's no cosine, I have negative 8a minus 3b is going to equal 0, whereas that negative 8b plus 3a is going to equal 2. So I'm just going to rearrange it so I have it a's together and b's together. So I have 3a minus 8b equals 2. So now here you have a system of equations, okay? So here you have a system of equations, and you're just solving. So you could do a bunch of different methods. The method I'm going to choose is just to multiply the top by 3 and the bottom by 8. And this way I could then cancel out the a's and solve for b, and then go that method. You could use some substitution method. This is called elimination method. What am I doing? Sorry, that should be an A. Okay, so you have something like this, looks like this. Here you get negative 73b equals 16. So b is going to be negative 16 over 73. What I do is I just take this, I plug it in, right, for my b value. So I'll have negative 8a minus 3 times, and then I'm just solving. So I have 8a So A is going to be a negative, actually my bad, positive 6 over 73. So now for my particular equation, what I'm going to use is the A and B that I have here, right? And plug it back in to that particular solution. So my particular solution in this case, y of p, is going to equal 6 over 73 cosine 3x plus negative 16 over 73 sine 3x. All right. So that's example 2. Now example 3, all right, we want to, I'll do all the steps this time in example 3 to find a general solution. So if you have y double prime minus 2y prime minus 3y equals, now this function, all right, so take each thing separately, right? So if you notice here, this is linear, and here you have the exponential. Okay, so what we can do is let's go back up to the table. Okay, and what I want to do is break it up into polynomials. So I want to use, because it's linear, I'm going to use that number 2, ax plus b. And because I have the exponential, I want to use some form of this, okay? So it gets to be a little tricky, but I'll show you what I mean by that, because you got to think of your product rule, okay? So, where am I at? All right, so here we go. So I have y of p is going to be made up of a linear function plus this exponential, but I want to include a product rule there because the reason why I know that is I see this x, okay? So y of p is going to be, let's say, ax plus b, that's my linear, plus, now make sure you use different variables here, c, x, right, because there's an x, e to the 2x, that's always going to stay the same, plus, now, I'm going to use d, but you could use a different letter because that kind of looks like a 0, so I'm going to use e, and then lowercase e to the 2x, all right? So then that is your particular solution. That's the way it should look. So when you do this, now we're doing the same thing. Y prime of p, I'm just going to get a. Now this is a product rule, right? B is constant, so it's going to be c e to the 2x, right? and then plus 2cx e to the 2x. Okay, and then plus 2e e to the 2x. The second derivative, a is a 0, right? Here we get a 2e to the 2ce plus, here we have another product rule, so I'm going to get 2ce to the 2x, and then plus 4cx e to the 2x, and then plus a 4e to the 2x. All right. Now, next step, so let me just clean this up. So I get a 4c e to the 2x plus 4cx e to the 2x, and then plus 4e lowercase e to the 2x. So let's plug this stuff in, right? So it's going to be a little bit of, you need a little room here, right? So you're going to have, plugging this in here, so we have 4c e to the 2x plus 4x that should be a c, plus a 4cx e to the 2x plus 4 capital E e to the 2x minus 2 times this whole thing and then minus 3, and then the y sub p. Okay, let's clean this whole thing up. We wind up getting let's see. We got a negative 3. Start with the constant. Negative 3ax minus 2a minus 3b minus 3cx e to the 2x, and then plus I have 2c minus 3e and that's e to the 2x. All right, so just when you're doing this, be careful on your, simplifying. I think that's everything, unless I missed something. Okay, just watch, and you can check my math. Let me know if I made a mistake. Okay, so now what this is equal to is going to be this whole right side that we have up here. So that equals the 4x minus 5 plus 6x e to the 2x. So now you could set up things that are together, right? What's the coefficient of x is 3a. And that's going to equal that 4. Negative 3a is going to equal to 4. Our constant that we have is this whole thing here, and that's going to equal negative 5. This 6 will be that negative 3c, right? And then we know that this has to equal 0, just based on matching them up. So I'm going to have negative 3a equals 4. I'll have negative 2a minus 3b is going to equal negative 5. Negative 3c equals 6. and I got the 2c minus 3e equals 0. So I know A is negative 4/3. Alright, I know C is going to be a negative 2. Okay, if I plug in here, I get negative 2 times negative 4/3 minus 3b equals negative 5, right? So I have 8/3 minus 3b equals negative 5. So negative 3b is going to equal a 23, negative 23 over 3, so B is going to be a positive 23 over 9. Good. And E, right, because you'll have, just to show you, I'm plugging in that negative 2 for C, so I would have negative 4 minus 3E equals 0, so E is going to be negative 4/3 as well, right? So now our particular solution, what I'm going to do is I'm going to take A, B, C, and E and plug it back in to what I have up here, okay? So my Y of P equals negative 4/3 x plus the 23 over 9 minus 2 x e to the 2x, and then minus 4/3 e to the 2x. Now remember, when you're solving these problems, they do take a while, and we have to go all the way back up and solve the left side as if it was equal to 0. So what I'm going to do is take this left side here and just finish, no, my bad, sorry. This left side, I went too far up. Okay, that left side, and solve, and then put them together. So here you have y double prime. So keep in mind, this is important, that's part of our solution. So you have y double prime minus 2y prime minus 3y. Now make this equal to 0 and solve like we normally do. M squared minus 2m minus 3 equals 0. So here I'll get m minus 3, m plus 1. So I know m is going to be 3 and m is going to be negative 1. So y sub 1 is going to be e to the 3x, y sub 2, e to the negative x, and then put that together. So here it's y sub c is going to equal c1 e to the 3x plus c2 e to the negative x. What you're doing is you're adding these two together, right? So my final solution is going to be, or my final general solution is going to be c1 e to the 3x plus c2 e to the negative x, and then minus 4/3 x plus 23/9 minus 2x e to the 2x minus 4/3 e to the 2, sorry, e to the 2x. Okay, so that's what happens there. And this is your general solution. So they can take a little while. Your algebra skills have to be up to par. Okay? Now, I'm going to show you example 4 just because I want to show you the glitch and what you should do if this happens. Okay, so now here you have this setup. So if I'm looking for a particular solution, I'm going to say, oh, this is nice. It's just going to be a e to the x, right? But when I take the derivative, right, I get a e to the x, second derivative, a e to the x. And when I plug all of this back in, right, back in, I get a e to the x minus 5, a e to the x plus 4, a e to the x equals 0, and what happens? Everything winds up canceling out, and I can't solve it because I get 0 equals 0. Well, that's great. but it's not helping me find what is this value of A. So what you need to do is you need to add a product rule to this. Now remember, like when we're up here, okay, and you're doing, where am I at? All the way up here with a product rule, right? If you notice, I did the product rule here, I did the product rule again here, right? You add that other x in there. So instead of doing this, right, we don't want to do that because that doesn't help us. We're going to now make our particular equation ax e to the x plus b e to the x. And now when you do your derivatives, you'll have a e to the x plus ax e to the x, and then plus b e to the x. Second derivative, a e to the x plus an a e to the x plus ax e to the x, and then plus b e to the x. So we could simplify this to 2a e to the x plus a x e to the x plus b e to the x. All right, now when I plug in, I could then solve, and what will happen is I'll have 2a e to the x plus ax e to the x plus b e to the x, and then minus 5 times a e to the x plus ax e to the x plus b e to the x, and then plus 4 times a. Okay, so let's see. So I have a to the x. So here I'm going to wind up getting, right, a negative 3a e to the x minus 4 well, that's nice. And you can see all the rest cancels out. Right, did I cancel? Yeah, I canceled everything else out. And then here, right, we could go back up and set it equal to that. E to the x. Okay, and now you could solve where you get 3a has to equal 8. So a is going to be negative 8 thirds. And then we could write our y of p to be negative 8 thirds x e to the x, and you could see that in this situation b is going to be 0 because we canceled out that portion of it. Okay, so when you're doing this with the glitch, right, just add another x into the problem, right, and make it like a product rule. That should help you. I mean, you could use the book example as well. That could help you also. So just be aware of that little glitch that you could see.